Alright, so chapter 2 notes. Are as follows. You'll see up here that a function, f of x, is equal to a times x minus h squared plus k. This is the way the book teaches it. I will teach it a little differently. Yeah, you should write this down. Just know that I'm teaching it kind of the same way. It's just a little bit easier, right? Remember I said when we put outside the box is that vertical stretch. The other thing they're talking about is the x-axis reflection. What that means is if it's negative, it's going to change from this to this. Okay? It reflects across the x-axis. That makes sense? So, that's all that's happening there. If it looks like this, then now it looks like this. Does that make sense? So, that's when it's negative. Right? When it's negative, the coefficient out front, when the x is negative, or this is negative, because that's going to make the x negative, right? When the coefficient in front of the x is negative, then the parabola is a frowning parabola, right? So it looks like a frown. If the coefficient is positive, then it smiles. It's really easy to remember. Coefficient in front of the x is negative, right? So it's like this. X squared or 3x squared looks like this. Negative 2x squared looks like this. Okay? Real easy. If the coefficient in front of the x is negative, or the a in this case is negative, it's frowning. If it's positive, smiling. Okay. We know that the thing outside the box is the vertical, right? The vertical stretch or compression. What they don't have is a horizontal stretch or compression. What they're doing is they're pulling everything out from in front of the x, and all they're doing is a vertical stretch or compression. So in essence, I guess I could say that I've been teaching it pretty like the hard way. You know, I've been teaching horizontal stretch and compression. Take you that step above where they're going, right? And then the horizontal translation, right, is always inside the box. When you're moving, the opposite x is always inside the box, right? And then the vertical translation is outside the box, the green part. Okay? Okay? So outside the box, right? Horizontal or vertical translation. And all that means is if I got something like this, 5x minus 6 squared plus 4. Okay? What this is telling me is that it's a vertical stretch. Why is it a stretch? Because it's bigger than 1, right? This is telling me, my blue and my green. This is telling me, right, that it's a horizontal translation. But remember, x is to the opposite, right? So it's not going left, it's going right. Okay? So, translation right by 6. And the way I would look at this is go, oh, it's x minus 6. Well, I know x do the opposite. What's opposite of minus 6? Plus 6. So I would translate this into right 6. See what I'm saying? That's the way I taught you. So we're just going backwards. If it's right 6, then it's x opposite, right? Minus 6. And so then it'd be x minus 6. Or right 6, x opposite plus 6, actually. Sorry about that. So that would be x opposite plus 6, because that sign would be different, right? So x opposite, you change that to x opposite plus 6. So what does plus mean? Plus means right. And so you're translating it backwards. You want to go backwards the way we came. And so right 6 would be x opposite, right? Because it's going right, plus 6. And then opposite of plus is minus. So we're just going backwards and forwards now with it. Shoot.
It's back on.
Okay. Okay, so that's all this is talking about. And then here, the vertical, right, is saying it's plus 4, right? So f of x plus 4 just means that we're going up 4, right? F of x plus 4 just means up 4. So when I ask you to go backwards on the test, I'm going to ask you, hey, this is right 6. This is up 4. Okay? And it's a vertical stretch of 5. Now if I had something in here, it would be a horizontal stretch. Right? Or horizontal compression, depending on what was in there. Okay? I may, because of this, I may stop doing that with you guys on your tests. Since they're not asking it of you. And I haven't seen a horizontal stretch in squares. Because things kind of go weird for me when I'm doing these. So maybe that's why. Maybe because I need to pull it out all the way. So we're going to focus on how this is set up. So we're going to go with strictly vertical stretches and no horizontal compressions or stretches on our squares or on our cubes or on anything like that. Okay? So that's that as far as like moving the function around, right? Moving the parent function of x squared. Remember, this is just the parent function of x squared, right? And then what we did was we moved it right 6 and then up 4, and then we stretched it a vertical stretch 5. Vertical stretch means it's going to be actually tighter. So it's going to become more tight than the normal because we're pulling it up. Okay? And so instead of this more rounded one, we're going to have a little tighter one. That's it. That's all we're doing. Okay? Next is in the chapter is that we need to be able to graph. Okay? Graphing is pretty important. There we go. I created this 4-step method plus 1. Okay, so this will not be in the book again, but things like it will be in the book. And the reason I show this to you is so that you know exactly how to graph quadratics. Okay, so if I want to graph this quadratic, okay, I look at this and I say, the way the book has you do it is, well, the front coefficient tells me what? Smiling or frowning? Frowning. So I already know that this looks like this, right? I know that it looks like that. Now, the thing is, if I want to put it in that term, I've got to pull out the A. And then that means I've got to pull out the A and, divide by 3 to everything. It's going to put decimals in there and stuff like that, but then I can move it, right? But the way I graph it is direct, it's exact. If I do the first step, you have to know how to take the derivative. Okay? Now the derivative is really, really simple. It's just 2a plus b. Okay? So remember, ax squared plus bx plus c equals 0. That's a quadratic. That's what a quadratic looks like. Okay? We ready now? Yeah. Big time. This will be in your cheat sheet. But there's a way we can find the derivative. It's a calculus step. It's called the power rule. Okay? And the power rule says this. I take this exponent, multiply it by the first coefficient. What's 2 times negative 3? Negative 6. Then I subtract 1 from it. Okay? So 1 from 2 is just 1, right? So 1 from 2 is 1. Okay? And then I've got, so this is the f prime of x, or in other words, the first derivative. Okay? And so then I take 1, and this 1 times 12 is just negative 12, right? So again, like I said, if this is a and this is b, then what is 2 times a? Negative 6, right? And what's b? It's negative 12. Now, the derivative also says that there's an x to the 0 here, and when you take that 0 times 10, you get 0, right? So it just goes away, and that's what happens in the derivative. It just goes away, that last number. Okay? So all we have is this, and then what we do is we set it equal to 0, because what a derivative is the slope of a function. Okay? It's the instantaneous slope of the function. Okay? And so at a point, and we're thinking, okay, well, if I have a thing that looks like this, right? And I look at the slope right here, what's the slope going to be? What's the slope right here? Positive, right? Goes up from left to right. Okay? Good try. But then what's the slope over here? Negative, right? Goes down. And they're always going to change, right? All these slopes are going to change. Correct? More or less positive, negative, right? Depending on where you're at. Except for one point, and that point is here. What does that slope become? 0. Yes. And that's our maximum point on this function. It would be called our minimum point on this function, correct? So it's what we call our max and min. Okay? Another thing is, in calculus we call it a max and min. Right now in algebra 2 or trig, we're going to call it our axis of symmetry. Okay? Because that's where the function becomes symmetrical, where we could fold it on itself. Does that make sense? So our axis of symmetry is at this point, at where the max or min is. And to find that max or min in calculus, we find the instantaneous slope at 0. The instantaneous slope is 0. And that's why we're plugging in a 0 here. That kind of makes sense? Okay? So we plug in the 0 and we just solve. Okay, so I add 12 to both sides. I get negative 6x is equal to 12. I divide by negative 6 and I get x is equal to negative 2. Okay? And that's my axis of symmetry. Does that make sense? So that's my axis of symmetry. Okay? Now, after I have my axis, I just plug it in to f of x. Okay? So I take this f of the axis, in this case negative 2, right? And I plug it into the function. Negative 3 times negative 2 squared minus 12 times negative 2 plus 10. and I figure out what that is. Okay? So I've got negative 2 squared is 4. 4 times negative 3 is negative 12. Minus minus makes a plus. 24 plus 10. Now you're always going to know you're doing this right if these two are halves. You'll know right away you did something wrong if these two are halves. They always are halves. Always, always. I've been doing this now 20 years and I'm like, never found one that was a half. Except when I was wrong. Except when I multiplied wrong. Right? So, remember, when you're squaring a negative, the negative becomes positive. Right? So that students make mistakes on that. Okay? So, just remember, these should end up being halves of each other. Okay? And I should end up with 12 plus 10. Okay? And then, basically, that is 22, yeah? And so, basically what's coming up here is f of negative 2, right, is 22. What that means is that my vertex, right, is at negative 2, 22. That's my vertex. That's my, in this case, that is my maximum value. Okay? All right. The next two steps are really easy. Okay? The next two steps are super easy. So we've got f of 0, and I plug that in. Well, negative 3 times 0 squared minus 12 times 0 plus 10. Well, that's 0, right? And that's 0, so that's just f of 0 is equal to plus 10, right? And that's where this comes from. F of 0 equals c. That last number in the quadratic. Okay? So my point here is 0 and 10. Okay? So that was really easy, yeah? Because it's always going to be that. It's always going to be this last number. Okay? Now, here's your check method. Your check method is I take 2 of these axes. So 2, right, of the negative square 2's, right? And I plug those in. So that's f of negative 4, yes? Okay? And I plug that in. So I got negative, what do we got here? Negative 3 times negative 4 squared minus 12 times negative 4 plus 10, right? And so these should be opposites. They better come up as opposites, yeah? Okay, so I do this. I go negative 4 squared. What is negative 4 squared? Positive 16, yes? Okay, so 16 times negative 3. So that's 30 and 18. So it's in negative, right? So 16 times negative 3 would be negative, right? 30 plus 18, 48, right? And then negative times a negative is a positive, right? And I've got 4 times 12, which is 48. See how those cancel? And I get plus 10. So again, I got negative 4 and 10. That's my other point. Okay? That's this. I should have that in red. That's my other point of symmetry. Now, if I want to graph this, sorry, real quick, just making sure. Okay. Now, if I want to graph this, I have a 10, I have a 4, I have a 10, I have a 0, okay, and I have a 22, right? Negative 2 and 22. So I need to be able to go down 22 or up 22, right? So I got to be able to go like 5, 10, 15, 20, 25, right? So here's 20 and here's 25, right? And I got to go negative, so let's go 1, 2, right? And at negative 2, 22, I'm looking at this point right here, right? I'm looking at this point right there, okay? And then from that point, I grab this purple one, 0, 10. Well, 0, 10, that's right here, right? So I'm going down like that. And then the red one, that's -4 10. So 1, 2, that's -4, and 10 is like there, right? So I'm coming down like that. And that's my graph. It's that simple every time. Okay, now later on, not today, but later on I'm going to show you this +1 method. That'll be on probably tomorrow. Okay? And the +1 method just checks where these cross. Where do they cross the x-axis? Okay? By finding what we call the quadratic formula. Okay? And that'll let us know where they cross the x-axis. Okay? And that's it. That's your notes for today.